Being a geotech engineer, I have to say that the profession is really interesting as well as challenging. It's interesting in the sense we have each site which is very different from the previous one. So it's like each location we have to identify what is the type of soil and recommend the foundations for that. It may not be applicable for the other location. So as well as it's very challenging because we have to select the right type of foundation and go for it. Otherwise, it's going to be a huge cost implications in later stage. So our topic for today is soil investigation and selection of the foundation type. Let's move on to the presentation. The contents of today's webinar is introduction. We'll see why soil investigation is required, objectives of soil investigation, foundation recommendations, how we can take, then some common problems encountered. This based upon my present experience. So this may vary depending upon the engineers. Also, we will see a case study and we'll move on to the conclusions and career path and job opportunities. So introduction. When you join with any industry and if you are given a project, at the beginning of the project, once the site is cleared, we have to go for the topographic survey and the soil investigation. So these are the first activity which happens in any project. Subsoil investigation helps us to determine what is the type of soil and what are its engineering properties which will be used for a foundation design. So it's very important to get the soil investigation done correctly. So there should be a certified engineer at site who will be visualizing the investigation and ensuring that it's done as per the right practices. If the soil investigation goes wrong, then based upon that, we will be working on the foundation system. So that's going to go wrong and later it may be creating problems. Based upon the soil report, we have to select the type of foundation that should be satisfying the structural requirements as well as it should be cost effective. So what is the actual requirement of soil investigation? If we see a structural engineer, he works with concrete or steel usually. So the material what he is going to use is known to him. Also, if you see highway engineers, they are selecting the rock or soil from some borrowed position, so they know what is the properties that is going to be used and will be used. But for a geotech engineer, in each site, we have to use what is the available location soil. So that conditions have to be analyzed. For that, we require the soil investigation to be performed. So we'll move on to the next slide. So we'll see what is the objective of the soil investigation. So by soil investigation, we are getting a 3D image of how the soil profile looks like. So here we can see how the ground profile varies. This is generally for all sites. It may not be a level ground. So in such conditions, we will have a finished ground level, or here it is the road level. So since this profile is higher than the road level, there will be some cutting involved and here there will be some filling involved. So this will be identified by the topographic survey. And then if we see the soil strata here, here it is stiff clay followed by rock. So if we are taking a borehole here, that borehole will show stiff clay with rock. Whereas if we come to this location, it is soft clay with sand, then followed by stiff clay and rock. So we can see how the soil profile is varying horizontally as well as it's varying vertically. Suppose if we have borehole taken only here and we are taking the design, it's for the design, then we will design it as per stiff clay condition, which is not correct because a foundation if we keep here, we will take the properties of the stiff clay, whereas the same depth we have soft clay here. So it is very important to get the right number of boreholes to get the correct image how the site looks like. So by soil investigation, we get a 3D image of how the soil will be there. Also, we have to identify what is the groundwater level, which is very important in our determination of the foundation. These are some common testings. So here we can see the most common method, which is the standard penetration test, which is being used all over the world. And this is a test fit. In standard penetration test, as we know, we will be able to get what is the penetration resistance at different depths. Also, it will be possible to collect the samples. That samples will be retrieved and taken to the laboratory for performing the soil test, like grain size, Atterberg limits, or the shear test, consolidation parameters. So all those testings will be performed. Apart from this, we have cone penetration test, which includes static or dynamic test, or it can be field test like vein shear test. But those are not very much common. Widely used as standard penetration test. And here in test fit, the advantage is like we are having a clear visual observation of how the strata is. So if here there is not much variation seen, but if the ground soil strata is varying, we can clearly observe it. Also here we can get huge amount of samples. Like for example, if we have to design some roads, then in that case, we have to do the CDR test, which requires huge amount of samples. So in such a case, we have to go for the test fit. But the disadvantage of such a case is, we can go up to maximum 1 or 2 meters depth or maximum to 3 meters depth. More than that, it will require some shoring system, which will make it more expensive. So in case of getting more data, we'll go for SPT test. So as I said, we have to position the borehole such a way to get the data for the entire site. So investigation has to be based upon what is the structure we are going to do. So if it's like a high-rise building, then it may, for the location where it requires pile, we may require a deep borehole. Or if it's just a small structure, light loaded structure, then we will have a lesser borehole depth. So depending on the size of the structure, depending upon the layout, we have to position the boreholes. And depth of boreholes shall be such that it should cover the influence depth of the structure. So this is, here I am showing just a typical layout of a sewage treatment plant, which I usually work here. So here, what we see in the layout, here the sewage pipe is coming. So it goes to a preliminary treatment unit where the screening process happens, and there's a grid chamber where the small particles settle down. And here there is a sequential batch reactor, then chlorine tanks, which are all related to the sewage treatment plant. So for me, here important structures are this one, this structure, all these structures. So here I have to position one borehole here. I have to position one borehole here, maybe one here. Depending on this size of the tank, I may have to give more number of boreholes for this tank. Then I may give one borehole here, one here, which is the sludge part. So this layout may call for some 6 to 7 boreholes. When we have a bigger layout, suppose if this tank is having one more portion, then it will require more number of boreholes. So depending upon our layout, we have to fix how many number of boreholes are required, depth of the borehole. So here I am showing how is the influence depth of the foundation comes. So suppose here we have a foundation. So this part if you are seeing, when the foundation is loaded, the soil below, immediately below the foundation will have the maximum intensity of loading, and when it comes down, the loading decreases. So here it's like the loading faced by the soil is 0.1 times of the total load. So this happens at a depth of 2B depth, 2B influence, where B is the width of the foundation. So we have to get the borehole done up to this depth. Suppose it's case of a strip footing. We term a footing as a strip or a wall footing when the length of the footing is more than 5 times the width of the footing. So in case the length is more than 5 times the width of the footing, it's a strip footing. So in such a case, this ratio becomes 0.1 at a depth of 4B. So for strip footing, the influence depth is 4B, and for a isolated footing like rafts or any other rectangular sizes or circular sizes, we will take it as 2B. So suppose here if we have this SBR tank, based upon my previous projects, I know mainly we will have this tank with a wall footing all around the walls, and inside the slabs, it will be a grade slab. Grade slab means it's a thin slab which will be just connected to the wall footings with some double bars alone. So this grade slab will have the weight only from the liquid which is retained. There is no moment transfer happening between the wall to the slab. So here I have a wall footing. Say I am assuming it may be a 4 meters wide. So influence will be 4 times of width of the foundation. So it's 16 meters. And maybe the depth of the foundation, it may be 2 meters. So 16 plus 2, it's 18 meters. So I'll round off and give 20 meters deep borehole. So this way we will give the depth of the borehole. Another important thing to be noted here is, depending upon the location, it will vary. Suppose we have a project in Kolkata. Usually Kolkata soil is very weak. We'll have very soft clay in the top portion. It may be up to 15 meters, we will have very less SPT values. So in such a case, we may have to go for pile foundations. So in such a case, we have to go for a deeper borehole. So that idea I have only because I have a prior knowledge of Kolkata soil. So when you're starting a project, it's always better if you are able to collect any nearby soil report, either from internet or from your teammates or other companies. Anywhere, if you're able to get some idea about the soil prior, then it is better to get the investigation to the right depth. So once the soil investigation is done, whatever the field data is prepared is called as the field bore log. So this field bore log, when it is reported, it looks like this. So this includes what is the project for which it is performed, who is the client, and what is the diameter of the borehole which is made, and what is the casing. So here it is 150 mm, which is the most common diameter which is used in India. And what is the boring method used? Here it is rotary method. Then previously, as we have seen, the level of the borehole, the ground level may vary. So here the level of the borehole is very important to know. Depending on the levels also, we have to identify how the ground is varying, and we will have the groundwater level. So here we can see depth of the borehole. Here it is 35 meters. So 0 at 0.75, here we will have what is the soil description which is seen at site. So it's like silty clay followed by sandy silt, and what is the color which is observed. All those things will be reported in the field. After the samples are collected, what is the type of sample collected? It's a disturbed sample. Here UDS means it's an undisturbed sample collected, which is usually done for clays. So here silty clay, undisturbed sample is collected. So this undisturbed sample will be taken to the lab and used for performing the engineering test, like shear test or permeability, compressibility, all such things. So here as we see, SPT test is performed at 3 meters. So what is being done at site is, first we have the level ground. The rig will be positioned at the ground level. Then we have to do the rotary drilling as per this method used here. Rotary drilling is done till 0.75 meters. Then the undisturbed sample is collected by putting a thin walled tube, and then it is pushed down into the ground, and it is retrieved to collect the undisturbed sample. And the sample from the middle of that collected material will be used for the testing. Then after reaching 3 meters, it is changed to split spoon sampler. It will be positioned and the hammer blows will be given. As we know, 63.5 kgs falling free fall through 75 centimeters. For the first 15 centimeters, we are getting here 5 blows. That is the seating drive. So this will be ignored. Next 15 and next 15 is 7 and 8, which will be summed together, 7 plus 8, 15. And that is reported as the SPT N value. So depending on this N value, our soil consistency will be defined. So here it will be medium density. So next it's going like 3 meters we have SPT performed here, then 6 meters again SPT, at 4.5 again undisturbed sample is collected. So as we go down, here we can see some values being reported like 50 in brackets, it's like 11 centimeters. What it means is like, usually the investigation agencies will report SPT more than 50 as a refusal strata. So here, when they are doing 11 centimeters itself, it's more than 50. So they are not doing it further and reporting it as 50. It means like it's coming to a very dense refusal condition. But still, it is a soil. They are able to use the same drilling bit for doing the further boring. So here we can see it's all dense soil. So in very dense condition, they will not be able to retrieve the undisturbed samples. So here we can see all the tests performed is SPT only, because undisturbed samples they cannot retrieve. So only disturbed samples collected from the split spoon sampler will be used for the testing. Moving forward, From the SPTN value, also we can find out some correlations. Like whatever this samples collected here, undisturbed samples, will be used for the lab test and given that will give the shear parameters. But there is high chance that it can be erroneous. So that check we can do by using the correlations. This is based upon Indian Standard 6403, which is the code for bearing capacity calculations. In this code, we have a relation between SPTN value and angle of internal friction of the soil. So if we have a SPTN value of 20 for a sand, then we may interpret an angle of internal friction of 33 degrees. This can be used for the calculation. Similar way, we have SPT versus cohesion value also in the case of clays. So this is taken from Foundation Design Manual from N.V. Naik. So here SPTN value versus unconfined compressive strength is reported. So after getting this unconfined compressive strength, we can use it to find the cohesion or the undrained shear strength of the soil. So these are like some checks for whatever shear parameters are reported in the soil report. So as I have told, like we have covered what is the soil investigation procedure. So after this investigation is done, the agency will be giving us a soil report. The soil report will cover what is the type of test, what is the purpose for which that's performed. Then it will include this board log sheet what we have seen, then the lab test results performed, also the supporting graphs. Then they will give what is the foundation recommendation. So we will move on to foundation recommendation part. Foundations, it can be a shallow foundation or pile foundation. Then depending upon the type of condition, it can go to a ground improvement or combination of the methods. By combination, I mean in a layout, we may not have all structures to be very high with very high loads. We will have some small chambers or small buildings which will be possible enough to be rested on a shallow foundation. So each site will have a combination of the foundation types. We'll just briefly go through the types of foundations. So shallow foundations, as we know, it is used for transferring the building loads to the underlying ground. It's mainly used for firm soils or in the case of light loads. Pile foundation is used to transfer loads to considerable depths. So when there is a weak soil, we will take piles to transfer the loads to a hard strata, or it need not be a weak soil, but the load from the structure is too high that the soil is not able to take. In such a case also, we have to go for the piles. So these piles can be made as a driven one, or it can be a board and then can be precast or cast in place. Now we will see some ground improvement options available to us. So what we see here is the available ground we are modifying to suit our requirements, and then we are going for the shallow foundation. So here the types are, first is mechanical modification, means what is the structure of the soil that is getting modified mechanically. Here some physical and chemical modifications, then hydraulic modification, then there can be modification by providing some inclusions and confinement, or it can be again a combination of the above methods. So these are some methods which we use. Let us go in some detail. So mechanical modification is like, here we use some mechanical equipments to modify the soil. So like soil density gets increased. In case of impact roller, this drum is having the weight to give the impact to the soil, and this will compact for 2 to 3 meters of depth. In case of a smooth reel roller, it compacts 200 to 300 mm. So in the first case, we had seen some portion where filling is to be done. So when the filling is to be done, we have to go for layer by layer compaction. So first we have to place a 200 mm layer, then we have to go for the compaction by the smooth reel roller, which allows that number of passes, maybe some 6 or 7 passes is usually given. So that will compact the soil to some 95% of the standard Proctor density. So such way we have to ensure what is the density attained after the compaction. Then we have sheepfoot rollers, which is mainly used for clayey soils, pneumatic rollers also for coarse grained soils. Then this is dynamic compaction. So in dynamic compaction, here we can see there is a heavy weight which is lifted by the crane. So the height of the lift depends upon the boom height. So it's usually like 10 to 40 meters. It can lift up the weight and it's allowed to fall down. So here we can see what are the craters formed by the free fall of this. So this is densifying the soil. So this method depends upon, like, we have to have a very clear land, which is because the vibrations involved here should not be affecting any nearby structures. It is widely used in Middle East countries. So whatever methods I'm showing here, it's like we are not going to use all these in our projects. So we have to know what are the available options, and we have to take by deleting whatever options not possible. We have to select the right option. Now what we have seen is just modification by using some equipments. We are now going to see physical and chemical modification. So in this method, what is done is some additives are used and the soil is modified. So physical modification means it may be a natural soil, or industrial byproducts like slag or fly ash is used to mix up with the soil to improve its properties. And chemical modification means lime or cement is used to modify and improve the properties. So we can see this is a method of grouting. So here in this direction there will be some grout hole which is first made, and then the grout slurry which is made, that cement slurry is pumped into it to fill the holes. So this also has different methods, like it can be jet grouting, it can be tank grouting, so, or pressure grouting. So this is just one method I'm showing, and this is like stabilization with lime and cement. This is a mass stabilization method. We are just mixing up the soil. So it depends, like whether it's feasible or not. Such things has to be studied.